Good morning, students. I trust that you are all doing well and you are keeping to the rules. Okay, so we want to continue our lecture today. Most of the time you hear people, especially politicians, arguing about price increases. So the price of today compared to the price of another year. Now, all these arguments are normally based on index numbers. Take note that the topic is index numbers and not indices. All right. So we want to look at what index numbers are. What are the economic significance of index numbers? Right. So first of all, let's go through our study objectives. At the end of the session, you should be able to understand one, the purpose of index numbers. So what purpose does an index number serve? What is the relevance of index numbers? We know that we sometimes compare. For example, if your salary in last year or last 2 years was 2,000, and then this 2020 it has increased to, let's say, 2,200, right? So we can express this, the price or the salary in year 2000 relative to the current year. So the price in the current year relative to the price in the year 2000. Okay. We also should be able to calculate index numbers for changes in the value of a variable. So we can calculate the price relative. So the price of a commodity this year relative to the price of that same commodity last year. Or we can also calculate the quantity relative. The quantity in this year relative to the quantity last year. Okay. And then also be able to change the base of an index. Okay, so we normally denote, let's say, price as P. So the base is denoted as P subscript 0 or P subscript O, but then we say P subscript 0. And then the current year will be P subscript N. Okay, so if you want to calculate the relative change, you see in the value or in the price will be Pn over P0 times 100. And normally this is conventionally expressed in percentage form. Okay, so use simple aggregate and then mean relative aggregate. The advantages of using a simple aggregate, that is where we are put the prices or the values of commodities for a particular stretch of years, let's say from 2010 to 2015. Are you okay? To compute the index numbers. And then we have other index numbers that is known as the Pache and the Laspers. So the Laspers actually compares index numbers using base weighting. So we weight all the values by using the base, which is denoted by P0 or Q0. And then the Pache uses the current weighting, denoted as Pn or Qn. Okay, so what are index numbers? Now, an index number is a relative number, right? It's because it relates the relationship between two values, and it expresses this in a conventional form as percentage. Okay, so it expresses it in a percentage form, conventional. Okay, so an index number is actually used as a measure of the change in the value. That is, it could be, the change in the value could be prices or quantities, as I've already mentioned, of a group of items. So these items are commodities. So we have Milo, we have milk, we have sardine, we have tomato, and so on. So commodities over a period of time, right? So of commodities over a period of time. Now, this may be a price index or a volume, and volume can also be expressed as what? Quantity index. So it is not a price indices or quantity indices. No, it should be, it's an index, not indices. Okay. Now, what is price index? So as we have seen on the slide here, we said that an index number is a number that compares the value of a variable at any given point in time with its value at a fixed reference point. So the reference point is what we call the base point. We use it as a base. The fixed reference point is usually called the base period. Okay, so that was what I was saying. And the associated value is called the base value. So in business, an index number measures percentage change in the value of some commodity over a period of time. For example, if your salary in the year 2015 was 1,000 cedis and it has increased to, let's say, 15,500 in 2020, what will be the change? The change is the difference between your price and your salary, that is the 1,500, less the 1,000 cedis all over the 1,000 cedis times 100. That is the salary in the current year less the salary in the previous year all over the salary of the previous year multiplied by 100, and then you get a percentage. Okay, so we need to calculate these simple index numbers, but before that, let's look at examples of a price index. We have what we call the consumer price index. But price index actually is a measure of the change in the money value, of a group of items over a period of time. So a measure of the change in the money value of a group of items over a period of time. An example here is consumer price index, the CPI. You've all heard about the consumer price index. We also have what we call cost of living index. You see, so we hear people say that the cost of living is high, and it's low, high, low, and so on. And then retail price index. These are all examples of price index. Then we also have quantity or volume index. And what is quantity or volume index? This is a measure of the non-monetary value, you see. So quantity is non-monetary. So non-monetary value of a group of items over a period of time. An example here, a typical example here is what we normally call productivity index. Productivity index. We also have what we call the index of industrial production. Index of industrial production, and then index of agricultural production, right? So we have industrial production and then we have agricultural production. All right. Then we have what we call, in fact, you need to understand these terms before we bring in the calculation. That's why I'm going through that. So price relative, what is price relative? So suppose there is only one commodity in the economy. If there is only one commodity in the economy, with a base year price of P subscript O, and then the current year price is P subscript N. Are you okay? I think I've indicated this already. Now the price relative will be Pn over Po times 100. So that is the price in the current year over the price in the base year times 100. And that is what we can see on the slides here. Now, suppose the price of a 330 moles can of Coke was 2 cedis in January and 2.2 cedis in February and 2.8 cedis in March. Okay, so this one is based on monthly. Now, so the percentage increase from January to February will be the 2.2 minus 2.0 over 2.0 times 100. So that will be 10%. The price of the canned Coke increased by 10% from January to February, right? That is what it means. But we will normally write this 10% as 110. We add it to the 100 and say that it's 110 because the 100 is the base. So we just add it to the 100 and then that will be 110. Now, the same increase from January to March will be the 2.8 for March minus 2.0. Remember that here, January is the base year. Are you okay? Over 2.0 times 100, that will be 40%. So in index number form, we'll say that it's 140. So the price of 330 ml can Coke increased by 10% from January to February and by 40% from January to March. In index number form, the 10% and 40% increase will be added to the 100, as I've already indicated, you see, giving 110 and 140 respectively. So the price index of 330 ml can of Coke in March was 140 relative to what? January. That's why we say it's a relative number. So the number relates to a particular period. Okay. So any increase or decrease must be related to some time period. Yes. Otherwise, it is meaningless. You see, so when you say there has been increase in price, increase in price from where? You see, that is why we say that if it does not relate to a particular period, then it's meaningless. Now, let's also look at quantity or volume relative. So what we have just talked about is price relative. You see, so quantity relative is the quantity produced or sold. So what has been produced or sold in the base year. So if the quantity produced or sold in the base year is Q0, and then it has increased in the current year as Qn, right? Then the quantity relative will be what? Qn over Q0 times 100. Qn over Q0 times 100. So what we have here is that throughout this lecture, we'll let P0 be equal to price at the base time period, right? And Pn be the current time period. In the same manner, Q0 will represent the base time period, and then the Qn will represent the current time period. So IP and IQ will be the price index and quantity index respectively. These are just variables that we are choosing to represent the calculations. So for any time period, then price relative, you see, price relative will be Pn over P0 over times 100. And then quantity relative will also be Qn over Q0 times 100. Okay. So let's look at another one called value relative. Before we look at this example, value relative. Or let's look at this example first, right? So the price of a quantity of a product A from 2010 to 2014 was as follows. Using the year 2010 as the base year, calculate the price index from 2010 to 2014. So we have from 2010 to 2014, and we are using 2010 as a base year. So in this case, all the figures relating to 2010 will be represented by P0, and all those represented in the subsequent years. So 2011 will be Pn. If we are calculating the price index for 2011 relative to 2010, 2012 relative to 2010, 2013 relative to 2010, and then 2014 relative to 2010. So it's a very simple formula. So for the year 2010 is a 50 over 50 times 100. So the price Pn is 50 and P0 is also 50. So year 2011, that will be 60 over 50 times 100. So that will give us 120. 2012 will be 55 over 50 times 100. So that will be 110. And then 2013 will be 65 over 50 times 100. So that will be 130. And then for 2014, that will be 70 over 50 times 100. So that will be 140. Okay. But I was saying that we need to look at another formula, that is the value relative. When we say value relative, then that is the value of a commodity normally is defined as the product of the price per unit, the product of the price per unit and quantity per unit, right? Or and quantity. So value in base year is P0 multiplied by Q0. And value in the current year or any other year will be what? Pn times Qn. So if you are calculating the value relative, then I need not write. Do I have to write this? Okay, so you can write it as I'm saying it. So that will be Pn Qn over P0 Q0 all times 100. And value relative could also be P0. We can separate it now. We have Pn over P0 in brackets, and then another bracket Q0 over Qn over Q0 times 100. Or value relative could be price relative times quantity relative times 100. You remember that price relative is Pn over P0. And then quantity relative is also Qn over Q0. So when we multiply the two together, we get what we call value relative. All right. So here we have an index relative. So index relative, sometimes called relative, is the name given to an index number which measures the change in a single distinct commodity. Change in a single distinct commodity. So let's say we have 2013 and 2014 items. So we have video recorder and then 30-inch television. So the price is PO for the current, the base year, and also the quantity that has been sold. As I told you, I said what has either been produced or sold. So what has been sold in the base year was also Q0. And then the price in the current year, so we are taking 2014 as a current year, that will be PN, and then what has been sold is also, sorry for that, it's also QN. So the price for video recorder at the base year was 500 cedis, and the quantity was 40. And the same price for 2014 of the current year was 542 cedis, and the quantity was 28. The corresponding prices and quantities for television was 410 and 25 for 2013, and then 465 and 42 for 2014. So let's see how we calculate this. So you see, for video recorder, the price index is the normal thing we have been doing, 542 over 500. So that would be 108.4. And then the quantity index will be 28 over 40, and that would be 100, that would be 70, right? So when you look at the table, you see, so 542 is the current year over the 500, which is the base year, and that's for the price relative. Quantity relative is 28 over 40, and that will be 70. So the same applies to the television set, which is 465 over 410 for the price quantity, and then 42 over 25 for the for the price relative, and 42 over 25 for the quantity relative. So we have these figures, 113.4 and 168. Okay, so these figures, if you want to calculate, you see, here you can be asked to calculate for the value relative for each of them. So the value relative will be this 108.4, right, multiplied by 70 for the video recorder. And then for the television set, it will be 113.4 multiplied by 168. Okay. Now let's look at, sorry for that. Okay. Fixed and chain-based relative index numbers. Fixed and chain-based relative index numbers. Okay, so index numbers are usually expressed relative to a fixed reference time point. So if, for example, we are choosing 2010, and then we calculate all the index numbers from 2011 up to 2020 with relative to 2010, then that would be an example of fixed relative index numbers. You see, but if from 2010 we calculate the 2011 index numbers relative to 2010, we calculate the 2012 index numbers relative to 2011, we calculate the 2013 index numbers relative to 2012, and so on, then that is what we call chain relative index numbers. So index numbers are usually expressed relative to a fixed reference time point. Now, on rare occasions, however, index numbers could be expressed such that the reference time point for the current period is the immediate past period, you see. So if the reference point is the immediate past period, for example, if you want to calculate the index number for 2020, and then you are using 2019 as the base period, you see, that's a typical example of what I've just said here. So when this is the case, the relative index is described as what? Chain-based, as I've already mentioned. Okay, so the next example illustrates the difference between fixed and chain-based relative index numbers. So let's look at that. Okay, so here we have the month. So we are calculating this example based on months. So from January to June, right? So production, we have 4563 January, 4245 February, 4841 March, 4644 April, and then 5290 May, and then 5156 in June. So if you are calculating the fixed, then it means that we are going to use, okay, now the question is saying that we should use February as the base, right? So it has specified the base. So if February, then the January one will be 4563, which is the current year for January, you see, over 4245 times 100. Okay, so for February, it will be 4245 over 4245 times 100, and that will be 100. So the January one, we have 107, and then February, we have 100. And then March will be 4841 over 4245. So that will give us 114. April will be 4644 over 4245. So that will give us 109. And then for May, 5290 over 4245. So for the fixed relative, we're dividing everything by the base. Okay. When we come to the chain, then we are still using February as a base. See, so in that case, for January, because January, we couldn't get anything because we are not really, we are using the same January, yeah. So for February, we have 4245 over the January one, which is 4563. You see, so the January, because we need to relate it to the previous year, which will be, that will be December. You see, so we don't have December, so the January will be dash. But the February, we are basing it on January, right? So that will be 4245 over 4563. Okay. When we come to March, then we have 4841 over 4245. So that will be 114. When we come to April, then it will be 4644 over 4841. Yeah, because the immediate month was March. No, but this should have been 4841, not 4842. So you can make that correction. So it should be 4841. Okay. Then for May, 5290 over 4644. So that of the April, right? And so on. So that is the difference between fixed and relative index numbers. Okay. Now, before we go on to this comparison of values at different times, let's look at, okay, we'll come to the aggregate method very soon. But then here we are comparing values at different times. Values at different times. So index at period n. So any period, right, will be IPN. That will be value at period n over base value. It's the same thing. Index at period m. So another period will be value at period m over base period, or base value is the same thing. So that's Pn over P0 will be equal to Pm over P0. So that is value at period n all over index at period n will be value at period m all over index at period m. Okay. So an example is this. The table below shows the monthly index for sales of an item. So the month is from January or month 1 to month 7. We don't know what month 1 is. So month 1 can be November, it can be September. So all we know is that it's from month 1 to month 7. And these are the indexes. So if sales in month 3 amounted to 240 units, so the index for month 3 is 98. Okay. What was the sales value in month 8? So we don't have month 8 in the table, but we are being asked to compute the sales value for month 8. So using what we have just described, the model. So value in month n over index at period n, right, will be value at period m over index at period m. Okay, so this will be sales in month 8 over the index in month 8 is equal to sales in month 3 over the index in month 3. So the sales in month 3 is 240. And then the index in month 3 is 98. So that will be 240 over 98. This will be equal to the sales in month 8 over the index in month 8. Oh, now we don't have, we are looking for the sales. That is what we need to look for. But I think the question should have given the index for in month 8, because I don't know how it got the 109, right? So because you have two unknowns, so there's no way you can determine any of them unless the equations are 2. So if you have only one unknown, then the equation should be 1. If the equation is only 1, then there should be only one unknown for it to determine. If the equations are, the unknowns are 2, then there should be 2 equations, that is simultaneous equations. If the unknowns are 3, then you have 3 simultaneous equations. That's how it goes. So this one without so I'm supposing that the index for the index in month 8 will be the 109, because when you transpose the formula, right? So sales in month 8, which is the 240, times index in month 3. Sorry, sales in month 8, which you don't know, times the index in month 3, that is 240, will be equal to sales in month 3 times index in month 8, which we also don't know. So finally, sales in month 8 will be sales in month 3 times index in month 8 all over index in month 3. And we know the sales in month 3 to be 240. We know the index in month 3 to be 98. So what is the sales, sorry, the index in month 8? So I think that is what is 109. If that is it, then that is that will be correct. Otherwise, there is no way we can compute that. Okay. Now, percentage change period. So here we have 5 periods, right? And their indexes are also provided. So at period 2, for example, there is a 20%, sorry, 20-point increase over the index at period 1. So you can see that from period 1 is 100 and to period 2 is 120. So the increase is 20. Now, the percentage change point is equal to index at point T0. No, it should have been the T1 minus T0, the other way around. I think that would have been the appropriate. So it's rather the current, which is the period 2, and then less the previous. So it should be index at point T1 less or minus index at point T0. That's how it's supposed to have been. Okay. So changing base period. Reasons for changing base period. Now, changing circumstances. An index should be reset whenever there is a significant change that makes comparison with earlier periods meaningless. Okay. So if, for example, the changes are said that is large, is relative to a very small one, then we need to reset it. So an index becomes too large. Say an index rises to 5,000, then a 10% increase will be what? 500 points. Okay, which is huge, which is a huge jump. Then a jump from 100 to 110. Okay, so you see when you compare the change from 5,000, a 10% increase in 5,000 will be that of 500. But a 10% increase in 100 will be just 10. So if you want a change from a 10% increase in 5,000 will be what? 550, 5,500. So that will be 5,500 compared to 110. You see, so when that one happens, then there will be the need to rebase it. Okay. The disadvantage is that changing the base period introduces discontinuity that makes comparison over periods more difficult. Okay. Now, changing the base of a fixed base relative. Changing the base of a fixed base relative. Okay, note that for any period, the following must hold. So these are all formulas. Old index at period n will be equal to value in period n over old base value. And the new index at period n will be equal to value in period n over new base value. So from these two expressions, we can have that old base value will be equal to value in period n. That is just by transposing the formulas, right? So this is the old base value in the first formula. Old base value is the denominator. So if you want to make the old base value the subject, then it will first of all go and multiply the old index at period n times old base value will be equal to value in period n. So that old base value will now be value in period n over old index at period n. And the same transposition can happen to the second formula. So we have these two formulas. Old base value will be value in period n over old index at period n. And the new base value will be value in period n over new index at period n. So these are the changing the base of a fixed relative. So then old base value over new base value. So you see that old base value, remember I cannot write, so if you have old base value over new base value, then this all of this, right, over all of this. So you can see that value in period n, they will cancel out if you are using the mathematical principles, right? So value in period n and value in period n, they will cancel out. So the formula will now be new index at period n over old index at period n. So similarly for, say, period m, so this is for just n. So if it's period m, then it's the same thing. Old base value over new base value will be what? New index at period m over old index at period m. Okay, so let's look at whether there's an example. So he's saying that it is easy to see that, that new index at period n over old index at period n is new index at period m over old index at period m. Therefore, between an old and new indices, it should be between an old and new index numbers. The formula below holds. Okay. You have to study a lot of formulas. So this is an example. Now, the following are index numbers relative to a base year of 1975. Now, suppose the base year is to change to year 2004. So you are just changing the year, the base year from 1975 to 2004. Now, calculate the new indices, calculate the new index numbers using the new base year. Now, since the year 2004 is the new base year, then new index at year 2004 will be 100, of course. So the index number for 2004 will now be what? 100. Okay, so we'll let xt, that is s subscript t new, be the new index at year t. And then x subscript t old be the old index at year t. Then we are saying that choices of variable S4, is it because it's 2004 or S5? Okay, so therefore S5 new will be that. Okay, let's see the solution. Now, using 2004 as a base year, the new indices are as follows in row 2 of the new table. Okay. Okay, so for 204, the old index, that was 1975 was 100. Now the 2004 will now be 100. So these are the indexes, or they are values. Okay, so these are the indexes. Okay, up to 2010. So 324 over 324. Of course, if the 2004 is now the base year, then that will be 100. But 2005 will be the 351 over 324, and that will be 108.3. 2006 will be 377 over 324, that will be 116.4. 2007 will be 384 over 324, so that will be 118.5. And 2008 will be 391 over 324, so that will be 120. And then 2009 will be 404 over 324, so that will be 124.7. Okay, but when you look at this calculation, it's just like computing the price relative and the quantity relative formulas. You can also use those formulas to compute it. So there is no need you have to worry, because you only have to note which year is the base or which period is the base. And then you just, because this is just like PN over PO. So if 2004 is P0, so this will be Pn, which is the 324 over P0, which is the 324. So that will give you the 100. This Pn is what? 351, P0, 324, Pn, 377, P0, 324. So it's the same thing. So you need not worry yourself going through that process. Okay. Then we also have the following indices monitor the annual profit of Tigo Company Ghana. Okay. So we have year 1 to year 8, but the index for year 1 to year 4 are not provided. And the index for year 6 to year 8 for index 1 are also not provided. Okay. So if the company had not changed to index 2, what values will index 1 have in years 6 to 8? Now, what values does index 2 have in years 1 to 4? If the company made a profit of 5 million cedis in year 3, how much did it make in other years? Okay, assume year 1 and year 5 as the base year for index 1 and index 2 respectively. Okay, so for index 1, we are using year 1 as the base, and therefore index 2, we are using year 5 as the base. Okay, so for year, index 2 of year, index 2 of the year times 230 over 100. So which one are we calculating? Year 6, year 7, year 8. So 230, 230, 230. Let me see. So year 5 is for year 5 is the base year for index 2. Index 2. So if year 5 is the base year for index 2, okay, and I want to calculate the index for the year 6, 7, 8. So 230 over 100, 125, 142, 160. Let me see where the 125. Okay, so the 125, 142, and 160 are the indices for year 2 from period 6, for index 2 for year 6 to year 8. And so it should be, if it is our Pn over P0, right, then for year 6, it should be 125 over 100 times 230. Okay. Okay, because we are using year 5 as the base for index 2. Okay, so the base will be 100. Okay. So that will be 125 times 230 over 100, 142 times 230 over 100, and 160 over 230 times 100. I'm just investigating the 230, which is constant throughout. Oh, okay. So the 230 is the only figure we have. Okay, so that is what we use. All right. Then for the second one, then it is also 100 over 230. So 100 times 100 over 230, 140 times. Okay. Okay. Let me see. So we have 100, we have 140, 168, and then 199. Okay, so let's see. And the base here is the for index 1 is year 1. Okay, so here again the 230 is appearing constant in all of the calculations. So for year 1 is 100 over 230. For year 2 is 100 over 230. For year 3, 100 over 230. Multiply by the respective index. Okay. So Now let's look at index numbers for more than one variable. More than one, then that will not be interpretable. Let's see. Sometimes an entity, such as a company, might be involved in more than one commodity. Okay, so you may, and normally companies don't produce just one commodity, especially if it's about commodities. They may want to produce, for example, Unilever has a variety of commodities. Even take the soap alone. So we have the locks, we have sunlight, Omo, and so on. So companies actually produce multiple commodities. Now, in such a case, an interest could center on composite index to represent the company. There are two ways of generating a composite index in such a case. We have the mean aggregate, and then we have the simple aggregate. So the mean aggregate relative index is just finding the average, the mean, dividing the whole thing by the total number of values, and then the simple aggregate. Okay, so what do you mean by mean aggregate and then the simple aggregate? So mean relative index at the period n, you see, is the sum of separate indices at period n over the number of indices. So you just sum up all the separate indices for the period, and then you divide it by the number of indices. So that will give you the mean. We understand average, mean. And the simple aggregate relative index at period n is also the sum of value in period over the sum of value in base. So where we have denoted this by variables, okay, so where I subscript ni is the individual index at period n for commodity I. You see, that's why I'm saying that the topic is index numbers, and not because then this should have read as the individual indices. But it's not indices, it's index. At period n for commodity I. And then V subscript ni is also and the V subscript 0i are the values for commodity I at period n and base period respectively. So K is a number of commodities present. Okay. So before we look at this example, when we say simple aggregate, it's a method. So if the summation of all base here, you see, we sum up all bases, so that will give you the sigma p subscript 0. And then the summation of all prices in the current year, so the sigma p subscript n. If we let these two quantities be the sum of the prices of all commodities in an economy, so we are summing the prices of all commodities in an economy. Okay, in the base year, so that is why we say it is P subscript 0. And current year respectively. So Pn is the current year. And then the summation of Q0, Q subscript 0, and the summation of Q subscript n also be the quantity produced or consumed in the base year and current year respectively. Then simple aggregate price index will be just the summation of P0 over the summation of Pn. Sorry, the summation of Pn over the summation of P0 times 100. And then the simple aggregate value will also be the summation of Qn over the summation of Q0 times 100. And this normally has some disadvantage of this method. It has some disadvantage. First, it ignores the relative importance of the units, right? the units of commodities. So it does not take the units into account. Then it also ignores the various units in which prices and quantities may be quoted. For example, we quote it as CD or per kilogram or per liter and so on. It ignores all these units. Now, these problems are overcome by using either the simple or arithmetic mean of relative method, as well as the weighted average method. So we'll come to the weighted average method very soon. Now, simple and arithmetic mean of relative. This is used to overcome the problem of prices and quantities quoted in different units. So if you have prices and quantity that has been quoted in different units, then you can use the simple arithmetic method or mean method. So in that case, the simple mean of relative price index is just a summation of the Q0 over N, where N is the number of items times what? 100. And then the simple mean of relative quantity is also the summation of Qn all over Q0 times N. Take note that the first one is Pn over Q over P0 all over N times 100. So when N is equal to the number of commodities under consideration, so N will be the number of commodities under consideration. Okay. Now let's look at this example on the slide. We have coffee, tea, hot chocolate, and then there are 3 items. These are their prices: 55 pesos, 28 pesos, 72 pesos for 2013. For 2014, the prices were increased to 62, 32 pesos, and 74 pesos respectively. For 2015, we have 64 pesos, 30 pesos, and 50 pesos respectively. Okay. So if you want to compute the fixed indices, then we are relating all the indices to 2013. You see, because 2013 will be the fixed. So for 2014, it will be 62 over 55 times 100. So that will give us 112.7. And for 2015, it will be 62 over 55 times 100. Sorry, 64 over 55 times 100. So that will be 116.6. And for coffee, for tea, then it will be 32 over 28 times 100 for 2014. And then 30 over 28 times 100 for 2015. And then for hot chocolate, the same approach. So first of all, we have determined the fixed indices. But when we want to calculate the relative mean index, then we're going to add all the indices we have computed for 2014, because we want to calculate the mean relative index for 2014. Right, so that will be all the indexes we have computed over all 3, because there are 3 commodities. And the same applies to 2015. We add all the indexes we have computed and divide it by 3. The simple aggregate relative index is also to add all the prices, you see. So that's what the formula I gave: 62 plus 32 plus 74. You see, all over 55. So this is the base and this is the current year. And again, if you come to 2015, this is the current year and this is the base. So that will also be summation of all this over 55 plus 28 plus 72. Okay. So let's move on. And the disadvantage, I think I have already mentioned the disadvantages in this method. Okay. So proceed. And this is just about having a unit one to be very huge relative to a very small one. Okay, so the mean relative index, however, does not suffer from this shortcoming. Yeah, so that is why we say we have the simple aggregate, which is the same, and must be used in such circumstances. So that is when there are huge differences between the values for the various commodities. For example, using the mean relative index, we have the mean relative index at the period n. So we sum all the separate indices at period n, and then we divide by the number of indices. So index for bread at year 2. This one is relating to 2.4. I think there's a table here. Okay, so it's relating to this question. So suppose the price of a loaf of bread was 2 cedis in year 1 and 2.4 cedis in year 2. Also, the price of a ton of butter was 2,800 in year 1 and 1,300 in year 2. Then simple aggregate index for year 2 will be 30 plus, you see, so 1,300 plus 2.4 over 2,800 plus 2, and that would be 100. That would be 107.15. And then suppose we were to ignore the value for bread. So you see that the value for bread was very small. Then in terms of price, we'll have 107.14. Now look at the difference. There is no significant change. So the two index values are almost the same, implying butter has virtually no influence on the composite index. You see, so this is one of the shortcomings of the simple aggregate index. All right. So if we want to do the average, that is the simple average, then we have 2.4 over 2 times 100, and then 30 over 30, 100 over 2,800 times 100. So the mean will be the two indices over 2, and that makes sense. So in this case, the two commodities contribute fairly to the mean index, you see. Okay. Mixing of two units. Mixing of two units. Now, sometimes two or more commodities might be in different units, which might result in meaningless or uninterpretable. I think I indicated somewhere along the line that where you have different units, then it becomes uninterpretable. So it's a composite index which you cannot interpret because the units are different. Now, example, suppose in 2014, 5,000 kilograms of seal in 1,000 gallons of diesel were sold, and 1,000 gallons of diesel, right? So 5,000 kilograms of seal and 1,000 gallons of diesel were sold. And in 2015, 6,100 kilograms of steel and 1,200 gallons of diesel were sold according to simple aggregate index. Then you're going to add for year 2015 will be 5,000 plus 1,000 over the 6,000 over 120 over 12,000 times 100. For 2015, no, this should have been, it should have been 60, that is 6,000 plus 12,000 all over. So it should have been the other way around, right? Because we are taking 2014. If 2014 is a base year, you see, but and moreover, because we are calculating the aggregate index for year 2015. So year 2015 with respect to which year? And we have only 2 years, right? So it can't be the 5,000. Okay, so the value obtained from the resulting composite index is million. Okay, in this one, all that we want to know is that when you have mixing units, then it's meaningless. But that can also be catered for the simple average method. When we divide the whole thing by the average, the simple mean, we just calculate the indices and then we divide it by the average, the number of commodities, and that will cater for the unit. So although it is meaningless, but it can be catered for. Okay, so weighted indices. Yeah, so this is what we call the weighted aggregate method. Importance of weight. Often a commodity or an aspect of a commodity could be more important relative to another commodity. So if, for example, we are laying much emphasis on the quantity compared to the price, or more emphasis on, let's say, bread compared to butter. Now, in this case, the manufacturer may want to place more emphasis or weight, you see, on the most important commodity. So if you look at bread and butter, then we can place more weight on one on bread compared to butter. Okay, the weight must be taken into account when calculating the index, not the indices, when calculating the index. Okay, so take for the example in the table below. Commodity A has a price of 2 but sold 20,000 units, whereas commodity B's price is 1,000 but sold only 2 units. Now, basing a simple aggregate index on price quantity will yield results that ignore the size of the quantity or price. When emphasis is on price, commodity B is more important than commodity A. The opposite is true when emphasis is on quantity. So that's when one is after the after price index, the quantity values could be used as weight. Similarly, when quantity index is desired, the price values could be used as weight. Okay. So let's see. Okay, so when we talk about weighted aggregate method, then that solves the two problems associated with the simple aggregate method, right? The two problems that we identified earlier. It solves that are associated with the simple aggregate method. The weighted aggregate method solves those two problems. So hence, important or weight are attached to the values, to the various commodities. Okay. So now, the above reasoning leads to a modification of the previous indices for more than one variable. So weighted mean or relative mean, you have the formula, and then the weighted aggregate index is also, we have the formula. So let's look at an example here. For the item A, B, C, D, we will see the weight that has been attached, and we can see that item D carries the highest weight, followed by A, followed by B, and then the last one, C. So if you want to calculate the weighted mean price index, right, and then calculate the weighted aggregate price index, okay. So we have the price PO, which is the base year, so 20, 55, 63, and then the PN, the current year, so year 1, year 2. So if you want to calculate the price index, we are ranking these items based on the weight. So you can see that D carries the heaviest weight. Okay, so that will be 24 over 20, 51, 55. So the current year over the base year times 100. So we have all the price index here, and then we also have the quantity. So when we sum up this, it gives us 2,195. Okay, so what is the total weight? You see, the total weight is 19. 8 plus 6 plus 4, 10, 11, 19. So we only divide our total figure by the 90. And then if you want to calculate the price, then we have 704 and then 627. So 704 over 627 times 100 for the weight. Okay, so let's see the requirement. So the weighted aggregate price index and the weighted mean price index. So they are all price index, right? But we want the aggregate and the mean. So the mean is that. Okay, so now we look at last pairs and then the per share. So last pairs method. Now this is a special case of a weighted aggregate index which uses base time period as weight. It uses base time period as weight. So the base time period value as weight. It is commonly associated with price and quantity. So the last pairs price index. This uses base period quantity as the base, you see, and then the last pairs quantity index. This uses base period price as the weight. So finding the last pairs price index is just what you have written there, PNQO, right, over POQ times 100. So the quantity index will be QNPN over P0 Q0 times 100. Now, what are the advantages of the last pairs or last pairs, as some will say? Now, first, it facilitates comparison since the denominator is what? Fixed. You can see that when you divide, all of them are divided by P0, Q0, so it's fixed. So that will facilitate comparison, yeah. If you are comparing two things, you see, so they must all be compared based on the same reference point. And the data collection is less costly, right? It's less costly and less time consuming. You can easily collect data to calculate that. And then more practicable method of measuring index numbers because it facilitates comparison. You see, because you can easily compare using this method, it represents a more practical method of calculating index numbers. And then index numbers can be computed at the beginning of the year once current year price is ascertained. So if the current year price is ascertained, then you can compute the index numbers at the beginning of the year. But one disadvantage is that, or two disadvantages, is that it overestimates price changes or inflation. So it overestimates price changes or inflation. Now, base year weighted or base year weight may be may be obsolete, sorry, may be obsolete, rendering the index number unrealistic. You see, so the base year, because it's fixed, so it may be obsolete, and then it will render the index number unrealistic. Okay, then let's look at the. Okay, so here there is this example which you can easily, for example, you only multiply 95 by 15 by 95 by 15 and then 4 by 25, right? And then 95 by 10 and then 4 by 10. You see, so here Q0 is a 95 and 15 is, or PN is 15. So using the formula, right? So is the last pair's price and then last pair's quantity. So it is just the 95 by 15. So QN PN and then plus 4 by 25 for B. And then you do the same down. So just calculating for the price and the weight for last person. And then the per share. This is a special case of the weighted aggregate indices, which uses current time period values as the weight for the index. So this one, it uses the current time period values as the weight for the index. Now, it is commonly associated with price and quantity. So the per share price index uses current time period quantities as weight. And then the quantity index uses current time period as what? Weight. So in this case too, we also have the quantity and the price indexes. So finding per share price index, this is a formula, right? So the per share price index, we have the summation of Pn Qn over the summation of P0 Qn, you see, and then the quantity index is the summation of Qn Pn over the summation of Q0 Pn, all multiplied by 100. So the advantages here is that one, it's realistic. It is since it takes into account current trends. Because when you look at the base, it is not fixed. But the disadvantages are many. It underestimates price changes or inflation. And then the denominator is not fixed, as I've already indicated, and therefore does not make comparison easy because the denominator is not fixed, so you cannot use it to compare. And then as a result, this method is rendered impracticable. Okay, so 4, data collection is more expensive and more time consuming compared to the last phase. And then index numbers cannot be determined until the end of the current year. Yes. So these are some of the disadvantages of this approach. So again, we have an example here. Number of units for year 1, year 2, and then for 4 types of products, and then the price per unit for year 1, year 2. So calculate the base weighted price and quantity index, and then calculate the current weighted price and quantity index. So this one, you are just to calculate the last pairs and the per share for the first one, and the last pairs for the first one, the per share is the second one, because you know what they stand for. Okay, so if you want to calculate the last pairs, then you see 20 by 11. The 20 is the year 1, and that is the base year. Multiply by the current year, which is 11. 55, year 1, and the base year. Multiply by the current year, which is 25. 63, 17, 28, 20. This one is not difficult, so I'm sure. Yeah, so we have the top. And then the bottom, we also have what? 20, 10, 23, 55. So now 20 and 10. 23 and 55, 63 and 17, 20 and 19. You see, if you are calculating for the last space. So you have the last space price, you have the last space quantity, the per share price, the per share quantity. Okay. There is one more important one that I need to add. That is deflation of a time series. Deflation. If we have a series of data, you see, recorded over a period of time, and we take account of the effect of price increases on this series. So we have a series of data, and we are taking into account the effect of price increases on this series. Now we are said to be deflating the time series. So the series is then said to have a real value, right? But where we do not take into account the effect of price increases on the series, then a value of the series is described as what? A physical or apparent value. So real value is apparent value over index number times 100. Now we can also use the concept of deflation to determine the purchasing power of a currency. Okay, so this is economics. So e.g. purchasing power of the cash and so on. Okay, but then this also has some problems, and which is about data collection. Data collection could be expensive and time consuming. Items to be included will be the items to be included in the construction of an index number is based on sampling, which has its own problems of sampling errors. And then we have the weight used may be out of date or may be outdated, out of date. Secondary data may have been miscalculated or misinterpreted. And then base year to be used should be the year in which no unusual events occurred. So that is about the deflation. Okay. So that will bring us to the end of this lecture. Our next lecture will be looking at arithmetic progression and geometric progression. That is progression. And then we go on to look at financial mathematics, probability, and so on. Okay. So have a nice day.